Hello and welcome back to AGT STEM. Today we're going to be watching a video on Hassium. So, without further ado, let's up to it.
Very good. What's the next element?
Hassium. I know nothing about Hassium. Should we make something up? Hassium is an element which I knew nothing about. But now I discover it's really much more interesting than I thought. We're here in the German state of Hesse at the Institute GSI, where Hassium was first made in 1984. Hassia is the Latin name for this part of Germany, Hesse, and hence it is named after the place it was discovered. So down here we have the accelerator that accelerated atoms of iron to bang into a lead target to make element 108, Hassium. Element 108 is actually in the same group of the periodic table as iron. That much I knew when I first talked about it. But what I didn't realize is that the element has a few atoms that are long enough lived that you can really do chemistry. So once the atom flies off from the back of the target, when it has been created, you can pass it through an atmosphere of oxygen and make the oxide, Hassium tetroxide, HSO4. And this iron, the iron of this molecule, this oxide, can then be followed to see how volatile it is and compared with osmium tetroxide. Osmium tetroxide is a white solid which is quite volatile. It easily evaporates, and you can show that Hassium tetroxide does not evaporate quite so easily. But it's amazing, this is an element. Only 40 atoms have been made, but you can tell how its oxide behaves. Osmium has one of the highest melting points of any element that's known. The people who make periodic tables where you have a sample of each element have great trouble melting osmium to make a sample. So it may be that Hassium would have an even higher melting point. It could be that it's the highest melting point element in the periodic table. But one would have to make a lot more atoms than that if you were going to find out what the melting point was. I think people may be able to calculate it, but the melting point depends on the strength of the interaction between the atoms. And unless you have quite a few atoms, that's very difficult to measure. And quite a few means many tens of millions, because even a small particle, so-called nanoparticle of metal, can have quite different properties from a large lump.
Well, that was a good video. I thought that once we got to the end of the periodic table, the last, I don't know, 20 elements, 18 elements, I guess, after we get to 100, they're all just going to be boring. At least that's what I thought. But then a lot of them are actually pretty interesting. And it's really cool how much you can do with something that's even just so small and you've only made a little bit of. Well, thank you so much for watching, and we'll see you next time. Stay smart. Bye!